Hi everyone. So let's learn about a very important law called as Pascal's law. So let me first give you the statement of Pascal's law. So the Pascal's law states that the pressure applied to an enclosed incompressible fluid is transmitted throughout the fluid without change in its magnitude. It means if there is an enclosed incompressible fluid, then if you apply pressure on it, it will be transmitted through the fluid without any losses. It means the same pressure will be transmitted throughout the fluid without change in its magnitude. So let's understand this in more detail. So here, if you see, we have got a container here, and in this container we have got an incompressible fluid inside the container. Now here, if you see, there is a surface of fluid which is exposed to the environment. Suppose if you apply certain pressure at this surface, so according to Pascal's law, this pressure will be transmitted inside the fluid with the same magnitude. So at any point inside the fluid, there will be same pressure acting, that is pressure P. So this can be shown like this, friends, that whatever pressure is acting over here, the same pressure is acting inside throughout the fluid. The surface of container will also experience the same. So let's consider one more example. So here, if you see, there is a pipe over here, friends. So in this pipe we have got an incompressible fluid. Now there are two surfaces of fluid exposed to the environment. Now the area of cross section at this opening of pipe is A1 and the area of cross section at this opening of pipe is A2. So now we shall put certain piston over here which is having load W1, and at the same time I am putting another piston over here which is having load W2. So it is very much visible from the diagram itself that the load W2 is larger as compared to load W1. Let's understand why this disparity of load over here. So according to Pascal's law, we have learned that this is the closed fluid here also, and here also the fluid is closed because the piston is kept over here. So whatever pressure is acting over here, the same pressure will act on this particular section, that is area A2. Now according to Pascal's law, friends, the pressure over here is same as pressure over here. Now we know that the pressure is the ratio of load to the area of cross section on which load is acting. So here pressure is W1 by A1, while here the pressure is going to be W2 by A2. Since these both pressures are equal, you will see that the W1 by A1 will be same as W2 by A2. It means when the area of cross section is small, on that load is also going to be small because the ratio has to be same. So if you increase the area of cross section, the load has to be increased in order to maintain the pressure. So this particular concept is very much useful for various devices such as hydraulic lift, hydraulic cranes. So let's make our concept more clear with the help of a real life example. So here we have got a small piston of hydraulic lift which has an area of 0.2 meters square. A car weighing 1.2 into 10 raised to 4 Newton sits on the rack mounted on the large piston. The large piston has an area of 0.90 meters square. How large force must be applied to the small piston to support the car? So if you read this whole question, friends, there are basically two pistons. One is having smaller area of cross section 0.2 meters square, and another one is having 0.9 meters square area of cross section, which is larger area of cross section. Okay, and on the larger area of cross section, a load of a car weighing 1.2 into 10 raised to 4 Newton is provided, and we have to find the load that has to be applied on a smaller piston. Let me show you the figure that will make the question more clear, friends. So here, this is the figure we have got. This is the hydraulic lift, and here at this section we have got smaller piston, and over here we have got a larger piston. So as we have discussed previously, according to Pascal's law, the pressure is going to be same. So over here load is going to be smaller because area is smaller, and over here the load is going to be larger in order to balance the same pressure because area of cross section of piston is larger. Here we have got the area of cross section as 0.2 meters square. It has written over here 0.2 meters square, and over here the area of cross section of larger piston is 0.9 meters square. And a load of 1.2 into 10 raised to 4 Newton of a car is sitting over here as it is mentioned in the figure. Now we need to find out the force acting on this smaller piston, that is W1. Okay. Now we are assuming that this whole fluid which is there inside in the closed channel, it is going to be incompressible fluid, friends. So this fluid is incompressible fluid. So let me call this pressure as P1 just for indication purpose I'm writing, and the pressure acting over here on the larger piston, let me call P2. So this pressure is P2, friends. But according to the Pascal's law, because this is an enclosed fluid, which is an incompressible fluid, okay? So this pressure P1 has to be equal to pressure P2. By Pascal's law, I can say the pressure P1 is same as the pressure P2. But as we know that, friends, pressure P1 is nothing but load W1 acting on the piston of area A1. So it is W1 by A1, and P2 is going to be load W2 by A2. Now, if you simplify this equation, you can easily find out the expression of W1, which is we have to calculate, that is going to be W2 into A1 divided by A2. And if you substitute the values, friend, the value of W2, that is the weight of this car, is 1.2 in 10 raised to 4. The value of A1, which is the area of cross section of smaller piston, which is A1, and A2, which is the area of larger cross section of piston. Okay, so we'll write down all the values over here in this equation. And friends, if you simplify this, if you solve this equation, you can easily find out the expression of the load required on the smaller piston. So you'll be getting this value as 2.7 into 10 raised to 3, or you can also write down 0.27 into 10 raised to 4 newtons. Now it is very much clear from the outcome of this particular question that the amount of load required at this smaller piston, which is W1, is far smaller than the load acting on the larger piston. Okay, so this is a beautiful example of the Pascal's law. So this is how we can use the Pascal's law for designing of various equipment such as hydraulic lift, hydraulic crane, and other various equipments. Thank you very much.